This is the second lecture of engineering materials and material science fundamental. In this lecture we are going to see properties of materials. The first property which we will be seeing is elasticity. It's a deformation will disappear, means once we load the material it will deform, and the deformation will disappear upon unloading due to the property called elasticity. So if we see in the stress strain diagram, when we start deforming it up to the elastic limit, if we unload it, it will regain its shape. This property of the material is called as elasticity, due to which it's regain its shapes. Upon deforming it further, it will take other path, but it will still have some elasticity. The second property is plasticity. So if we cross the elastic limit, if we go beyond it, then material will take other path. Let's say if we deform it to this point, B point, and after that it comes to this path, to this point. So this B dash point up to this B dash point, from C point to B dash point, it is elastic zone because it has regained its deformation. So A dash B dash will be the plasticity that is remained in the material. So it's a plastic strain, but the property due to which this plastic phenomena happen is called as plasticity. Is a material ability to deform under external load. So deformation here, which is a permanent deformation, is due to the plasticity of the material. The third property is the toughness of the material. So toughness of the material is the ability of the material to absorb energy until the fracture point. So in this mild steel stress strain diagram, this is the fracture point. So from this point up to this point, the area of this stress strain diagram will give the modulus of toughness, because it's a per unit toughness of the material. So this entire area will give the idea of toughness of the material and its material's ability to absorb the energy until its fracture. The resilience is similar to toughness, but its material ability or the capacity to absorb energy till the elastic limit. So till A point, whatever the area is there is called as a resilience of the material, and this triangular area up to A point is the resilience of the material. Next property is tensile strength. So tensile strength has two categories: ultimate tensile strength of the material and yield tensile strength of the material. So it's a material ability to take stress up to the point of deformation. The point of deformation is a yield strength, and up to maximum stress is an ultimate strength. So let me draw the stress strain. This is for mild steel. So maximum stress is up to this point, and yield point is this. So this strength will be yield strength of the material, SYT sigma, not SYT, it's YT. Sigma YT will be the yield strength of the material, and this point will be the ultimate tensile strength, sigma UT, of the material. And if we draw it for aluminium or some material in which there is no particular defined yield point, this is for mild steel, this is for aluminium. So here what we do is we take a deformation up to 0.2% strain, and we draw a parallel line with the elastic line or the slope of Young modulus. slope of stress strain curve, which is also known as Young modulus. We draw a parallel line for 0.2% strain, and this point wherever it intersects with this stress strain curve, we defined it as an yield strength sigma yt, and the maximum strength is the ultimate strength sigma ut of the aluminum or the material like aluminum. This is how we define the yield point in materials like aluminum. The impact strength is the capacity of the material to resist or absorb shock. So impact strength we measure by ISOD and Charpy test, and we prepare a specimen which has a V notch at particular angle, and we orient it in particular manner in ISOD and Charpy test, and we hold from one side, and we have an impact force from the other side. So due to this V notch, we can calculate the impact strength of the material. So ductility is like the capacity of the material to undergo deformation under tension. So whenever we deform the material in tension, how much it can deform till its break, or in wire drawing operation, how much wire we can draw, how much smaller diameter or up to how much length we can draw the wire is known as a capacity of the material for to undergo deformation, and the property due to which it happens is called ductility. Other property is brittleness, which is exactly opposite of ductility. So it's the tendency to fracture without deformation. So without deformation means there is a no ductility in the material. In fact, there is a limit that if there is a 5% or less deformation in the material till it fractures, the material is brittle, or if it is higher than 5% strain in the material, then the material is ductile. The hardness is the resistance of the material to plastic deformation by indentation. So indentation, we have a Rockwell hardness test, noob hardness, Vickers hardness test. Like that, we have a hardness test. Basically, it's a resistance of the surface deformation. We have an indenter which we try to penetrate on the surface of the material by some force, and how much it can penetrate inside the material is the measure of hardness of the material. So more the hardness, the less the penetration of the material. Like glass has 1500 Brinell hardness number, and aluminium has somewhere around 75 Brinell hardness number. So glass is more harder than aluminium. Creep is a plastic deformation of the material at a constant stress and elevated temperature for a prolonged period of time. So we have to keep our material in constant stress at higher temperature and for a longer duration, and we will see that there is a time dependent plastic deformation in the material without changing the load. This property of the material is called as creep. The last property is malleability. So malleability is the ability of the material to deform under compression without cracks. So ductility and malleability are kind of similar, but in ductility we give tension load, but in malleability we have to check the ability of the material under compression. So gold foils and silver foils we prepare extremely thin, they don't have any cracks. This is because they are highly malleable. Gold and silver are highly malleable. So malleability gives the ability to deform under compression without any cracks. If the material is ductile, it will be malleable, but if the material is malleable, it doesn't mean it will be ductile, because ductility is because of tension, and in tension there can be failure due to crack propagation, which we will see later. So these are the properties which are very basics and are often asked in various exams. And if you like this video, then please subscribe the channel, and we'll see some more concepts in the next lecture of this series. Thank you.